Well, good afternoon, good morning, or good evening, depending upon where you are in this world. And thanks for joining us today for this DevOps.com webinar. I'm Charlene O'Hanlon. I'm the moderator for today's event, and I welcome you. Before we get started with the webinar, I do have a few housekeeping items to go over. First of all, today's webinar is being recorded. So if you miss any or all of today's event, just know that you'll be able to access the webinar on demand following the event. We'll be sending out a link via email to the event on demand, and you can just use that. You can also check the DevOps.com website. It'll be listed there as well. And we are taking questions from the audience today. So at any time during the presentation you have a question for our presenters, please just use the control panel and submit your question, and we'll take a few minutes before the end of the webinar and go over those questions. Okay, with that, I would like to go ahead and present today's webinar, How Aporeto Secures Cloud-Native Apps Across Public, Private, and Hybrid Clouds with InfluxData. Our speakers today are Don Chouinard, who I know I just mispronounced his name. He's Product Marketing Lead at Aporeto, and Bernard van de Waal, who's Engineer at Aporeto. Thank you both for joining me today.
Thank you very much, Deb. And that was a fine pronunciation.
Thank you. All right, Don, I'm just going to turn it right over to you and let you do your thing.
Awesome. So, and thank you for all of the attendees. And I hope we have some good meat for you today. I think we do. Let's start out with just a little joke. Not everybody wants to think about security issues all the time, but somebody has to. And certainly, it's great to have you this morning and to kick off 2018 and have a discussion about how to secure cloud-native applications. So we're from Aporeto, and perhaps you've visited our website. You can see that we're all about security that transcends clouds. So it's about cloud-native security and also lift and shift security as you're moving to the cloud. And with the Aporeto product, what you get is the ability to strengthen your security, and I'm going to cover exactly what you mean by stronger security, Don. And also, strangely, operations are going to become simpler when you, if you decide to use the Aporeto. And this has zero touch for developers, so they don't have to go in and be changing any of their source code. That's very important. You don't want to change developer velocity. So as we're out talking to people on a daily basis, we're seeing some themes that are cropping up. And the first thing that people seem to be telling us without exception is that they are at their wits' end, trying to secure cloud-native applications using IP address ranges just plain doesn't work. Now, in the past, where you had your monolith and it was behind the firewall, you could put a rule into place that would give you a certain degree of protection for that monolith. And the monolith didn't change that often, and it always appeared at that address, so it sort of worked. Well, okay, so it doesn't work, because what's happening is the bad guys are getting through the hard outer perimeter, and they're getting into a low-value target, and then after they land, they're expanding. And it's not good. It ends up in the headlines. So we have all kinds of problems because security has been based on where the application is running or where the application components are running. And that's what we need to change. And that's what we're going to talk about, exactly how we address that problem. It's going to be vital. There'll be no microservices running in clouds until we get to a better security model, as you'll see in a minute. The second thing people are telling us is that they do realize that their frustrations with trying to keep all of the firewall rules and other rules of the security zones and their cloud provider all up to date, that's not working, and they're hoping that what they can get to is a security model where the security is attached to the actual application components themselves. Imagine if we could do that. Instead of where the component was running, the security is attached to that uniquely identified component wherever it happens to run. Therefore, it could be coming up on-prem. It could be coming up in a hybrid cloud or across into a multi-cloud environment. You could have, maybe instead of one, you have 10 of them or 20 of them, or you need 100 of them because of demand. And so the security would automatically move and scale with the application component. Wouldn't that be cool? So that's a great thing to think about, and I'm going to draw a picture of that just in my very next slide, actually. The third thing people are telling us is that they're going crazy with all of the different security rules. When you're in-house, you're programming your firewalls. When you might have some different sites and you're VPNing them together, and now you've got all this mishmash of address ranges, and you start to get yourself confused. And then you put some stuff up at Amazon or Azure or Google, and they have their own rules about how security is to be done. And so now, what are you supposed to tell your developers? What are you supposed to tell your ops people about how we're securing these mission critical applications? It's just all over the place, and it's very, very frustrating. So if you could move to one model, I think everyone agrees, that'd be kind of the ideal place to be. You can just use one model and deploy across sites, hybrid clouds, multi-clouds. Wouldn't it be great? And of course, we cannot impact the velocity of the developers. They don't want to think about security on a daily basis. They should not be required to. They should be adding functionality that moves the business forward. And security should just be provided for the application components. That would be the ideal scenario. Well, wait a minute. How am I going to attach security to all of these different microservices or containers? Well, the answer is they can be selected based on their labels. And as long as they're cryptographically uniquely identified, we can go in and secure them. And you'll see more about that in a minute. No changes to source code would be needed. So now let's say I have 4 application components, and I'm going to need some rules now. Okay, A can talk to B, and B can talk to C, but A can't talk to C, things like that, right? So that's not a problem, especially if you have a syntax that's human readable and understandable, a natural syntax. You just crank them out. Just do it. But if you have 100 or 1,000 application components, right, microservices, containers running around, then you're not going to be writing those manually. So you need the tool to help you here, to be in, let's say, a discovery mode, and to automatically make note of who's talking to and how often they're doing that, and to generate those security policies automatically for you, so that they can then be attached to the application components. So that's what people are looking for, and more, even more so, it's like, let's codify security. I mean, right now it's terrible. You have your artifacts, you get them through test, you get them, off the staging server into deployment, and they're being secured based on TCP/IP addresses. And that's being done at the last minute, and you're getting all these frustrations. What people really want is, look, I make a module, I check it in, and it gets security applied to it. I don't have to worry about it. Done. And when new modules come up, they get the security applied. And when an old module gets revised, the security just gets applied. And so I don't have to worry about this as a developer. And this is sort of like the nirvana for DevSecOps, that we all agree what we're going to do. We codify these agreements, and then the tools do the work to make sure that all the agreements are adhered to across the board with no hassle on anybody. That is the ideal scenario. Now, SecOps people, InfoSec, they're mostly interested in that visibility. When all hell breaks loose, it's like, okay, where, why, how long? How can we stop this quickly? How can we ensure it doesn't happen in the future? And when you're doing your security based on all of these different rules that are placed in the cloud, or firewall rules that are placed into equipment, you're not going to have visibility as to what's going on with the security posture of your application. You are not going to have visibility as to when the breach happened. You are not going to have the power to stop it immediately. So it'd be good if a tool set could provide that visibility and control. And the last thing is, just for little things like, I've got service A and it's talking to service Q, and they used to be in the same availability zone, and I'm good with them talking. I've blessed that. That's okay. But now Q is off in another availability zone, actually in a different geo. So you know what? Now I want all that traffic encrypted. Oh, great. Here we go. After I do my mutual TLS, I've got to go in. I've got to get some keys and get those doled out. And what about key rotation? And it's just a lot of work. Wouldn't it be nice if your security solution, you could just make a simple rule that says, all the traffic between A and Q will henceforth be encrypted. And boom, it just happens. The tool set just does all of the things that need to happen without you having to, fumble and mess around with keys and code things directly into your services. No one wants to do that. So that's what people are looking for. So we've got something at Aporeto, and I can describe it in a single slide, which is the one you're looking at now. So let's start at the base. You've got hosts, right? Because programs have to run somewhere. So you've got these hosts, and maybe you've just got 1, 2, maybe you've got 100, maybe you've got 1,000, and these hosts are running processes, right? Maybe they're Linux processes, maybe they are containers, maybe they're Docker pods, running on Kubernetes environments. And so what you need to do is onto each host, you need to install the enforcer. So it's either a Linux processor or it comes up as a container. And now once the enforcer is in place, what it's going to do is it's going to uniquely identify each of those application components. It's going to uniquely identify it based on its attributes. Yes, folks, I'm talking about attribute-based access control, which is what NIST told us we all need to move to. We got to get off this RBAC. This is not good. People steal the credentials. They get in. They move unfettered throughout the organization. You got to move to attribute-based access control. If each of the players can cryptographically, uniquely be identified, then we can start securing things. So the enforcer's on the scene, and everyone gets a unique ID. Now, of course, the enforcers, they need a boss. So they all talk to the controller or the security service, which is either running up in our cloud, so you don't have to set up and maintain it. We'll do it. We have a multi-tenant cloud. Or you can run it in your own cloud because you like the way that, feels. You want to have more control. No problem there. But the enforcers need a boss. So they're going up to the centralized security service. And what the biggest thing the enforcers are getting from the centralized security service is they're getting their security policies. And these are the policies that say which application components are able to interact with which other components within the environment, right? Those are the marching orders for the enforcers. Now, the cool thing here is that you've got centralized management up in a cloud-based a control plane up there. But the actual enforcement is taking place on each individual host. So this thing scales, right? It scales out. You have more hosts, you get worried, not a problem. When you have more hosts, you end up having more enforcers. And so all of the enforcement will take care of itself. We only take a little tiny footprint on each host in order to run that enforcer, and then everything can take place. Now, not only are the enforcers going in and enforcing the security policies, or perhaps they're in an observation mode and they're just checking everything out to create these security policies, but they also are sending telemetry data back up to the cloud. And that's where the InfluxDB comes in. That's where we need a database where we can be putting the time series data, and it can be coming in fast and furious at times, especially if we have large numbers of hosts involved. And so we love our InfluxDB. And so now the other thing, once you've got the information in the InfluxDB, is you can now go in and you can get dashboards. You can see metrics. You can see how things are running. You know what the coolest thing is? Forget securing. You can see all of the application components and the dependencies and their interactions. That's a picture most people long for, to get that picture. And not only can you see that, but you can also see all of the security aspects of what's going on with the dashboard. Now, I just want to cover one more thing on this slide, which is the whole root of trust thing, right? So you've got to have, X509, right? Everyone's hip to this. So you've got a root CA, and it has, it's got the root certificate, and it blesses the security service and says, okay, yeah, you're good with me. Yeah, okay, I bless you. You can now have power. Great. Security service now has all of these enforcers, and they all register with the security service, and the security service says, yeah, okay, yeah, you're not an imposter. You're good. Okay, I give you power. Enforcer 1. Enforcer 2, you have power. Enforcer 3, you have power. The enforcers now exert their power over the processing units, over the application components that are running. So this is the chain of trust. It's a cryptographically secure, strong chain of trust through which we identify each application component uniquely. There can be no imposters, no playbacks, no man in the middle. None of that stuff can happen. And after identifying the components uniquely, we go ahead and we enforce the security policies in a distributed fashion for scalability and high availability. That's it. That's how the Aporeto, keep that machinery in mind, because we're going to show you this thing in action, and these are the things that you're going to see. With that, I'd like Bernard to tell us a little bit more about how he went in and coded this to use the InfluxDB and such.
Thank you, Don, for the good introduction. And so first thing I want to cover today is why do we actually need a time series database? And so to do this, let's take a very simple example. Let's say a two-tier application that you can see on the right side of this slide. And what you can see is you can see a client, an external client that could be you over the internet. And then you have an application, which is made of a front-end container, let's say Nginx, and a back-end database. And so if Aporeto is installed into that application, let's say on top of Kubernetes, what happens is we are going to start to record every single event related to that application. For example, every single time one of your container or pods is going to start, stop, or restart, it will generate events. And so what you want to do with InfluxDB and with a time series database is really record all of those events in order to be able to replay them later. Okay? So, for example, on this picture, what you can see is the Nginx container is coming up at time 1 second, and this is going to generate an event together with all the labels and tags of that container, and it's going to be pushed out to InfluxDB. Let's say later that container goes down for any reason, it will also generate an event, and when it comes back up, another event. And so this is very important because it will allow you to audit, to replay, and to really be able to understand what happened in your cluster over the last days, weeks, and months. So the other thing we do also is we record every single flow. So every TCP connection into your cluster will also generate a full event. So the TCP connection, the source, destination, TCP source, destination port, together with a couple of labels and identifier of the connection itself. So we push this to InfluxDB, and again, it will allow you to see exactly who is trying to open a connection with which process or which containers. And so this is very key to be able to audit or to replay, let's say, fraudulent connections into your cloud. And so in this example, what you can see is you have a normally allowed flow between the client and the front end, and then another allowed flow between the front end and the databases. All of those will generate a normally allowed flow event to InfluxDB. But next to this, let's say you have a deny flow. This will be, of course, denied by Aporeto, but it will also generate a deny event into our databases, into InfluxDB. So later on, you can replay this and try to understand why all of those deny flow events happened, or even put a new rule that will eventually allow those if they were like a false positive or false negative. And so what we really do with InfluxDB or with a time series database is pushing two types of events, one related to processes. So every time you have a container or process event, when it goes up or down, and another one for flows, that is every time a flow is generated. It could be allowed or denied. Okay. So let's talk a bit about why did we choose InfluxDB. One of the key things for us was that we are using a large amount of hosts. We can go up to thousands of hosts, let's say on a very, very large set of Kubernetes clusters, in case you use multiple Kubernetes clusters. And all of those generate a lot of events. Every single connection will be one event. And so we wanted a time series database which is able to have a very fast ingestion rate. That was the number one reason to choose InfluxDB. The other one was HA, high availability. We wanted to be able to have not a single point of failure. And so InfluxDB made that really easy. We looked at other alternatives such as MongoDB or KairosDB or OpenTSDB, but none of those were like fast enough for us or not easy enough to put in HA mode. So next thing I want to do is go over a quick demo, which is called Apobir, which is on GitHub, by the way, if you want to see the source code. And so that demo is very simple. It's the same one as the two-tier application you could see before. You have a front end and a back end. The back end is a very simple web server, And then you have both a front end and an external client, which are attempting to generate or to query that web server. What we want to do with this demo is showing that front end will be able to query backend, but external will not be able to query backend. And so the key difference between those two clients is simply the labels that they got. So front end will get a label with role equal front end, and external will get a label with role equal external. Those labels, by the way, are very simple to set up. They are part of the orchestration system, such as Kubernetes, or they could be a label that you assign to Docker or to your process when you launch it. Those are not Aporeto specific. That's the code of the demo. And so let me switch to a terminal. Here we go. What I got right now is a very simple Kubernetes cluster running on GKE. If I do a kubectl get nodes, you can see that I got 3 hosts on GKE running Kubernetes version 1.7. By the way, you don't really need to know anything about Kubernetes for this demo, but just for information, it's running on top of Kubernetes. And so at this point, if I inspect all my pods or containers on Kubernetes, what you will see is that we deployed Aporeto on it. And you can see that we got the 3 enforcers up and running, 1 per host, as Don was explaining. And this means that at this point, every single process or container coming up on that Kubernetes cluster will be fully enforced by Aporeto. So let's launch the application. What I got is I got a definition of the Apobir demo application. And I'm very simply going to create that application on Kubernetes. So I'm just giving it the source file. Here we go. Creating a namespace, the pods, and a service so that they can reach each other. And so as soon as I did this, you will see the container starting up. If I query Kubernetes again, you will see that at this point, it's creating the backends, external and front ends. Each of those will get 3 replicas. So let me switch quickly to the Aporeto console. Here we go. And so what we did is, since we connected the Kubernetes cluster to Aporeto, you will be able to see every single one of those events. Like I explained, basically, when those containers start, they generate those events, and you can show them on the dashboard. So let me go specifically into the beer namespace that we use on Kubernetes. And what you see right now is all of those containers are up, and you see those red lines, which are attempted connections between containers or between pods. So first thing we can do, and by the way, those information are coming directly from InfluxDB. The enforcers push those information to InfluxDB, and our console is querying InfluxDB and generating that beautiful graph. So first thing I want to do is I want to filter based on tags or labels. So those labels are present in InfluxDB. They were pushed down by the enforcer. And first thing I can do is simply filter by role. And so what you can see is each of those pods or containers, since they got tagged with the different role equal front-end, back-end, and external, you can see now a more clear and precise view of your application. One thing is still wrong though. We wanted to be able to go from front-end to back-end and allow this connection. External to back-end should always be denied. What you can see right now is directly from InfluxDB is that all of those connections from front-end to back-end are denied, and we want to change this. So what I'm going to do is I'm going to go back to Kubernetes. Here we go. And I'm going to create a policy that allows that connection to happen. So that policy is in that file. There we go. And so right now, Kubernetes will allow those, will store the policy, and Aporeto will get that policy and allow it to happen between the pods from front-end to back-end. And what you can see happening right now is some of those red lines became orange, which means over the last hour, we got both accepted flows and rejected flows. That makes sense since I changed the policy from deny to allow. What we can do, and this is one of the InfluxDB capabilities, is aggregate flows over the last 30 seconds only. Here we go. And if we wait a bit, right now the running window will show only the flows from the last 30 seconds. So if we wait about 15 seconds right now, you will be able to see that those flows will all become green, which means that we only got allowed flows between front-end and back-end over the last period of time.
And these policies are all in a human readable form, so they can later be edited and adjusted.
Right, exactly. And that policy that I pushed, by the way, is right here. It's a backend policy.
Ah, perfect.
It defines that you can go
You
from
see it right
front
there,
end.
yeah, when role equals front end. Yeah.
You can go to role equal backend. Yeah.
Okay.
And this is graphically visible on the platform. And so again, that whole view of the system is directly coming from InfluxDB. We transform it a bit, but we use the aggregation function of Influx and we display it. And so the other reason why we want a time series database, as I explained before, is for auditability and replaying what happened in your cluster. So right now, I'm in live mode, which means I'm basically displaying the pod events from the last 10 seconds or 20 seconds and the flow events from the last 30 seconds. Okay, that's pretty much live. So if I go out of that mode, like this, what you will see is you will see every event happening over the last 2 days. You can change this, but in this case, the last 2 days, from Tuesday to Thursday. The other thing I can do is I can replay the events on the pod. And since I started this cluster very early this morning, nothing happened until I launched the Aporeto application today, like a couple of minutes ago. And you can see this right now, like this, up. There we go. And so everything is available over our API. You can query this and generate your own analytics on top of this information coming from InfluxDB. And so let me finish by simply showing you another cluster I got, a Kubernetes cluster that I call Scale. Here we go. And in this cluster, I let a couple of I let containers from that demo application running overnight with different policies scaling up and scaling down. And so if I go out of live mode, what you will see is, if I go out of live mode like this, and I display everything from Monday to today, there we go, and I replay this, what you can see is initially there was nothing, so let's forward a bit, and there we go. So there was some, there we go, our application was allowing traffic, then it grew, somehow it scaled up, then scaled down again and died. There we go. And so this is the quick view from the dashboard, but again, I mean, the key value that you can get out of it is you can query the API and really try to understand why some of those flows were denied. For example, here you can see that someone from internet tried to connect, and you can see which IP exactly tried to do this. Like this seemed to be a local IP out of the cluster that was not allowed, of course. Okay, so let me go back to the presentation and make Don a presenter again. There we go.
Awesome.
Thanks, Don.
Thank you, Bernard. And so now you've seen an example where we had the one server that serves up a random beer, 2 clients thirsty to get their beers. And we wanted to keep it simple just to, keep it very clear what it was that our tool was doing. But things can get pretty complex pretty quickly. If you take into account a standard 3-tier application that people tend to, be having this model in their mind from the past. And in zone 1, you'll have your web servers and you'll have a rule, an address rule that says anyone from anywhere can get to the web servers. Okay. And then you'll create another more secure zone, a zone 2, and you'll have a rule that says anyone from addresses originating in zone 1 are allowed to come into zone 2. And then you'll have another rule about, that only programs originating from addresses in zone 2 are allowed to enter into zone 3. And what you want is you want to secure this 3-tier application according to these green arrows. But what you get is something entirely different. When you do your security based on IP address ranges, you leave all kinds of unintended access routes. And you have zero visibility into the true application posture of your app, of the overall app. It's hard to figure out which IP address rules I would need to change if I introduce a new zone, if I move an application component for HA purposes or scalability purposes. There's lots of unintended paths. I mean, right now there's a rule that says The rule actually says anyone, we don't even care who they are, anyone from zone 2 can get into zone 1. What kind of rule is that? That's not much of a door. That's not much of a security system. So when you move to the correct model, where security is based on the application components, then instead of a rule that says anyone from zone 1 can come into zone 2, the rule would say web servers that are the Nginx web server that are in zone 1 can come into zone 2. So now you're getting very, very specific, that are being run on under a certain user ID, that have other labels associated with them. You can start to get very, very selective about who comes in and who doesn't come in. And you automatically close off all of these unintended paths that are used oftentimes for land and expand attacks, where people get into zone 2, which is the GUI center. You get through the outer shell of the M&M into the GUI center because you used a phishing attack, and the 8th time the person finally gave you the privileged credentials, and guess what? You're in zone 2 and you're the privileged user. Hey, have fun. You know, expand, find good stuff. Well, you can't do that. If Aporeto's in place, it's more than who is trying to do something. It's more than user ID. It's which process is trying to do what to which other process, and was that blessed? So the security picture, when you put the Aporeto in place, becomes very simple. It's exactly the green arrows that you had in mind. People will come to my web server. They will want a beer. The web server will go to the pick a beer service. It will get a random number from the random number service. It will get a price from the pricing service. You know, they will use databases. And in the end, the person's going to get a beer. And this is the only traffic that's going to move through this environment. And it wouldn't matter whether these application components are brought up in a private situation, private cloud, on-premise, whether they're brought up across a hybrid cloud environment. You know, you're going out and using some AWS or some multi-cloud, and you're bringing in some Azure, some Google. It doesn't matter where the components run when you attach security to the identity, the unique cryptographic strong identity. You got all that? Unique cryptographic strong identity of each application component. You got to know who you're dealing with. If you can uniquely identify each of the entities you're dealing with, then you've got some hope for some really nice security. The model becomes very clean. It's very easy to think about. The unintended consequences go away, becomes easier to manage. So that's why I was saying in the beginning, and you're like, yeah, well, we'll see, Don. I promised that we could increase the security for cloud native applications at the same time making them operationally more simple. And I know that was a big promise, but I hope you've seen that when you just move to this new model, that's what happens. Now, let's say you have a Kubernetes environment. So on Kubernetes, as you know, they've got the network policy resources. So you define these things, and they control ingress and egress between the services. Now, those network policy resources, those are just like what you want to have happen. The actual enforcement of that is done by a network plugin. And there's all, you know, I can think of at least 6 network plugins right off the top of my head for Kubernetes, and some of them are not very scalable. And some of them are kind of preliminary, but some of them are a little bit better. Well, we have an awesome network plugin. It's 100% compatible with everything that is Kubernetes, and that is how we fit into the environment. So we're completely compliant. If you have network policy resources that you're using, we'll abide by those. But you're probably going to want to move on to the larger model that and take advantage of these new concepts that I just talked about. So when you take and you take your stock Kubernetes and you go and put the Aporeto with it, now you don't lose anything. You've still got network policy compatibility. You've got control of ingress and egress traffic. But with Kubernetes, that's always based on address. With us, it's based on application identity, right? Component identity. You can now have strong identities for all of your application components and control the traffic based on that, which is a better model because you're using Aporeto with your Kubernetes. You can very easily request encryption between pods, and that's just a security policy. And boom, done. You don't have to write it. We'll take care of all the key rotation and the root certificate and all the things that need to happen. We'll take care of all that. You just need to create a very simple human readable policy such as the one that Bernard showed earlier. Now, you'll probably have a lot of application components, and you'll be loving the fact that you don't have to jam all this stuff into YAML. You can let us discover all of the components and generate the security policies automatically for you. You'll end up with a very highly scalable network plugin because we are proven out there in some large deployments. And you'll find that this is very easy to set up and keep the security running because of the model that we're bringing to your Kubernetes clusters. You'll get that real-time and historical visibility that Bernard showed you, and you'll also, not everything runs on Kubernetes, right? I mean, some of the services might be Kubernetes-based, but some might not be. Well, with Aporeto, we've got you covered. You can span those two. Or let's say you're all Kubernetes, but you've got multiple clusters. People do this because of address-based security. They have clusters that are at these different addresses in these different security zones. Now they want to pull together, one application across it all. Well, with Aporeto doing the security, that's not a problem. We'll pull together all of the pods running on anywhere within the cluster with one consistent model across it all. So that's how that works. So in summary then, and then we'll be more than happy to take questions. So please, think up your questions, type them in. Like we're ready. We're here for you to answer your questions. But while you're doing that, I just want to summarize a little bit and say that we love our InfluxDB. It's where we store all of our historical information and all of these metrics that are coming in, sometimes from large numbers of hosts. And we love the fact that we get high availability there and that it can keep up with the load. The programming model that we can use to put data into it and get the data out of it so that we can give insights. From the Aporeto standpoint, we're in here securing the applications based on the identity of each individual application component. So you're getting finer grained granularity to your security than you've ever had before. It's not like an address range with a whole bunch of stuff running in it. Each individual component gets secured, and that really helps to defend against land and expand attacks. It's kind of like what Tamiflu does, right? You need to isolate each individual component. And so this is, of course, enforced by the Aporeto enforcer based on security policies so that you get that consistent security model that runs across sites and clouds. You'll get that fine-grained security. And rather than saying, oh, well, here's a user ID that's now here that wants to do something, looks like privileged credentials, I better let them do it. It's like, no. What application component that has been uniquely identified running under that user identity is trying to do what? Oh, in that case, yeah, we'll let them through. Oh, in that case, no, we're not going to let them through. Right? So you get much finer grained and stronger security. It is easier to administer, and you will have an unrivaled security posture across all of your hybrid cloud and multi-cloud environments. So that is that's the bulk of the information we wanted to relay, and we'd be happy to open it up for some questions at this time.
Yes, great. So we've gotten some questions in so far, but there's plenty of time if you have a question based on today's presentation or just in general, I guess. Feel free to use that control panel. Get your question in, and we'll hopefully have enough time to get to all of the questions we're getting in so far. First question is from Greg, who asks, if we are calling an AWS service, do we need to have Enforcer run there as well?
You want to take that?
So can you repeat the question? So if
sure. If we as an organization are calling an AWS service, do we need to have Enforcer run there as well?
Well, if you got typically an AWS VM up and running, yes, you will need to have an Enforcer running on that AWS VM. And so, I mean, the demo we did today was based on containers, but we fully support processes or containers of any type. So yes.
So that's the case where you control it because you've spun up an EC2 instance. And by the way, we grab all of the tags out of the identity document from the EC2 instance. We have excellent integration with all things AWS. And so you brought up this EC2 instance. Well, that's a virtual host. And you want to put one enforcer onto each physical or virtual host wherever they happen to live. They could be in AWS, they could be on-prem, they could be anywhere. Now, the other part of it, though, is you might be wanting to access a service that you don't control. It isn't running in your EC2 instance. Now, in that case, what you do is you define it as an external service. And then that's what you do. You define it as an external service, and then that now has a name, and now that name can have security policies applied to it.
And the key thing with everything on Aporeto is you tag it and you label it. And so what we do is every processing unit or every container or every AWS process or VM will get tagged. And as Don explained, when you launch something on AWS, you automatically get those tags and labels from the orchestration system, from EC2.
Okay, so hopefully that answered the question. If it didn't, then type in another one and we will continue to clarify.
Okay, well, Greg just sent another quick message. It says, yes, not in our EC2, so thanks.
Right, yeah, exactly. So it's an external service that you're using. Cool.
Yeah.
Right. Like a DNS service or something like that.
Yeah.
All right, great. Next question is from An, who asks, can Aporeto handle 3 million plus transactions per day?
Is transaction TCP connection, I will guess. I will need to check for the exact number of 3 million, but I mean, that seems like an okay number if you have like very small TCP connections for an HTTP server or something like that. So yeah, I will guess. I mean, it's mainly what we do again with TCP or with any transaction or with any flow is we push those to InfluxDB, right? So that's basically the ingestion rate of InfluxDB. And we aggregate them before pushing them. So not every single flow is generating one TCP connection to InfluxDB. We put them together, and once every 5 or 10 seconds, we push that data to Influx. So
all right.
I think
hopefully
we can.
That
It'll be less about us keeping up and more about, do you have enough hosts?
Yeah.
All right, great. Okay, next question. How hard is it to get started with Aporeto in my environment?
Okay, yeah, because sometimes people think, oh, well, I'm going to change my whole data. How am I going to try this out again? So, actually, the best way, what we found is the best way. You come to our website, you get the you sign up, you get the download, you do the APO beer demo. Okay, fine. Now you're ready to get serious. What you do is you just choose an application that's usually it's a containerized application, and that runs on how many hosts? 2, 3, 4, 6. And so on those 6 hosts, then be they physical or virtual, you install the enforcer, and you're off to the races. It's pretty simple. You don't have to make a big leap of faith into technology that's pervasive and gets its hooks into everything that's in your production. Not necessary. Not at all necessary. Just pick one simple application. And the enforcer goes in very easy. It's a userland process, so there's no kernel modules or anything like that going on. So it's very easy to get the enforcer in place and then start to see what Aporeto can do for that one application. And usually people become very impressed with that, and then they start to get much more extensive plans for what it can do for them.
Awesome. All right, great. Getting some really great questions in, but there's still time. If you've got something for our panelists today, please go ahead and use that control panel, get your question in. Our next question is, now this is an interesting one. Doesn't microsegmentation solve the security problem for cloud native apps?
I'll take that one. Yeah, you know what? I actually love this question because imagine if you had all kinds of firewalls all over your enterprise. They're all different buildings and divisions and floors and projects, and they have all these firewall rules in them. Actually, half of those rules are obsolete. People don't want to touch them. They do. Who the hell wants to clean up the firewall rules? Nobody. No one dares to do it. And what this means is that new applications don't have the correct firewall rules in place, so they break, causing InfoSec untold headaches. And other things are open, security vulnerabilities are open, the doors that should have been closed and locked a long time ago. So the thing about microsegmentation is it doesn't help. It just gives you an easier way. Well, it does. No, I want to take that back. It does help. What it does is it allows you to boss around your firewalls and kind of get these rules under control so that you have at least some semblance of a grip of what's going on security-wise. But in the end of the day, you don't. Because you're doing security based on IP address ranges. It's a flawed model. It's like shoveling water against the tide. It's going to come right back in against you again. So this microsegmentation, it's all about this little IP address range, and then this other little IP address range, and then this other little IP address range. And it's not right. What you need to do is attach security to the actual application components themselves, and then all the headaches go away. You're at the right level of model, and life can be much easier.
All right, great. Next question. This one is really also very interesting from Ron, who asks, DevOps is starting to be considered by IBM z/OS shops with data in an open source or cloud solution. Would Aporeto provide a solution with respect to the mainframe?
Right now, we use like the C groups and namespaces of Linux. So we want you to be on Linux. So, and then you could be, you could be doing processes, you could be doing containers, you could be using any orchestrator you want, but it's Linux.
I mean, Linux for now, but we are really working to
Enforcer
on other platforms.
Yep, get in touch with us. We're all ears. We'd love to talk to you about your needs beyond Linux, because each conversation we have helps us to prioritize the other platforms. You know what needs to happen, right? We just need to put an enforcer onto that platform. And the platform needs to have the underpinnings so that we've got something like a C groups and names so that we can go in and do some enforcing.
Mm-hmm.
And like IP tables.
Gotcha. Okay. All right. Moving rapidly along here, we've got another question here from another Gregory, who asks, are there any license requirements?
Yes, this is licensed. Just give us a call. And it's there's open source also. There's Trireme open source project. We felt it was important to take the enforcer and to put that out in open source form to take some of the mystery off it so people could see how the enforcer works. But so we've got Trireme as the open source.
Right. So yeah, we got Trireme lib. So the key part of the enforcer, which is performing the TCP enforcement. So the way we do enforcement is we add data to TCP, and this is all open source. It's a library called Trireme lib, and we implement it with a couple of open source projects such as Trireme Kubernetes and a couple of others. And those really demonstrate how to use the key concept of the enforcer. Now, if you want the console and the visualization and everything, that's part of our enterprise products. But you can use Trireme and the open source, let's say, enforcer with Kubernetes. And it's an open source project called Trireme Kubernetes on our GitHub.
Excellent. All right. Great. Let's see. We have a couple more questions left, but if you do have a question, it's not too late. Just go ahead and use that control panel. Okay, next question. What languages are supported?
Okay, languages. Well, actually, that's what's nice about this is we don't care which language you wrote your application component in. Could be Node, could be Ruby, could be Python, could be anything you want. Because in the end of the day, we're picking up these containers, if you will. Sometimes they're Linux processes, but we pick up these containers based on the labels that have been applied to them. Some labels you apply, some labels get applied when it comes up on a given host. It will automatically be given certain labels. And we do our selection, our identification of the application components based on the labels, and the selection based on labels. So you could be writing in any language that you desire.
All right, great. Okay, looking at our questions here. The next question is, let's see. We've got so many of them here. Let's see. Oh, is this a service mesh?
Is it a service mesh? Yeah, that's a term that people are using now. It makes a lot of sense. And usually just to, so everyone's on the same page here, because you might not read the stuff every day like I do. So you've got, okay, so you're going to go containers for all of the obvious, benefits that you're going to get when you do that. and then you're like, I need an orchestrator. So you pick an orchestrator. You know, Kubernetes has a lot of excitement, but there are certainly other excellent orchestrators as well. So now you've gone containers, you made that decision, you've chosen an orchestrator, you've got that decision. Now you're starting to code up. Now, usually maybe you bring over a monolith, or maybe it's even better and you don't have to decompose a monolith. You're actually going to just go in and create a cloud native application. So you're going to have services, right? And these services are going to be created by small teams that can move quickly and innovate fast. And these services need to communicate with each other. And there's a lot of things that needs to happen between services. Sometimes traffic needs to be encrypted. Each service needs to be secured. Other things too. And so the concept that people have come up with is this idea of a service mesh. When I'm a programmer and I'm writing my service, there's a lot of stuff I'm not going to have to worry about because it will be provided by the service mesh. So in that regard, yeah, we're a service mesh. We're a security service mesh. You don't have to think about, there's no library that you have to program to. You just go ahead and write your service to do whatever you feel will move the ball forward for your business, and we'll apply the security after the fact based on the labels.
All right, great. Let's see, we are about 9 minutes to the top of the hour. We have time for a few more questions here. If you just thought of a question, you want to send it in, that's fine. If we don't get to your question during the Q&A period, the fine folks at Aporeto will have a copy of your question, and I'm sure they'll be more than happy to follow up with you post-event. Next question, let's see, what are the scalability limits?
Okay, I did touch on that a little bit. So, okay, so that's a broad question. So, but the best way to think about it, sort of just like logically, what you don't want is a central choke point happening. So, this is why we chose the architecture that we did, where the enforcers are distributed. Each host gets an enforcer. It takes a very small RAM footprint, uses a minuscule number of CPU cycles to do what it needs to get done. And so as the number of hosts grows, as the number of as the number of application components becomes massive, then the number of hosts is also going to grow. And with that, we'll have plenty of bandwidth for our enforcers. So this thing scales really well. Now, having said that, the enforcers are sending all of their information back to the cloud. And so you're going to want to look at your pipes there, especially if you're running across multiple sites. Make sure that your pipes are sufficient to, just kind of get all of that telemetry information out in an efficient fashion. But it usually is not too taxing. So those are my general statements about scalability. And for anything more, we should really get serious and have a serious, detailed conversation about what you're doing and and how we would fit into that environment. And while I'm on that, and waiting for my next question, I just want to be sure that everyone knows that you're invited to please come to the Aporeto.com website, where you'll find our data sheet and additional information on Aporeto. You can sign up for a more in-depth webinar. You can sign up to have a conversation with one of our security experts who will talk things through with you to see if this might be the right thing for you, and we're happy to engage further.
Okay, great. Let's see, I think we have one more question here. We'll go ahead and you actually may have addressed this a bit earlier also, but can Aporeto be used on monolithic applications that we are going to lift and shift into AWS?
I kind of hand waved on that, so now I'm busted on that. Now I got to go into it. Okay, all right, I get you. That's all right. I'm prepared for this question. So let's see, what am I going to say about this? All right, so you've got this monolith, and it's running behind your firewall, and it's a 3-tier. That's where I kind of touched on it. It's a 3-tier application, and the middle piece is like massive. It's like, instead of being services that call each other through RPCs, it's procedures that call each other through procedure calls, and so the whole thing's got to be released as one big lump, and it's difficult to all the things we talk about monoliths. So you still want to avoid this scenario as you start to open it up to maybe a hybrid cloud environment where the web servers are going to be up in your cloud provider. The middle tier logic might move up to the cloud provider. You might feel like you want the database on-prem. Sometimes people get this way. They feel it's more secure when the database is on-prem. And so now you've got all these different IP address ranges. So this is where you wish you had the Aporeto. Also, if somebody were to get into the monolith, like the important part, the application logic part, you don't want them to move unfettered across all of those Linux processes. You need to, for a high value application, you might want to say, hey, wait a minute, there's 3 dozen Linux processes. Let's give each one of them a little bit of a security perimeter. Let's let Aporeto uniquely identify each of these processes and put a security shield around it so that we're not subject to land and expand attacks. So, and eventually, monoliths get decomposed. They get decomposed into services. That's part of the journey to the cloud. And when you start to decompose, that's when you're like, aha, I have one consistent security model that works across sites and clouds, and as I go to decompose the monolith, I can use that same security model that doesn't bother developers. So that's kind of how we play into that.
Okay, great. We're about 4 minutes to the top of the hour, so I think that's pretty much all the time that we have for questions today. But Don, just want to confirm, these both products are open source, right?
Yes, the Aporeto, we talked about a couple of our open source projects. The Trireme, T-R-I-R-E-M-E, is how you look those up.
Okay, great. So they can folks can go to the website or GitHub to download if they want to try it out and maybe even contribute.
Yep, come to Aporeto.com. We have everything linked from there.
Great, great. So both InfluxData and Aporeto have trials available. So if you are interested in checking it out, feel free to just hit the websites and you'll be able to see it there. Don and Bernard, thank you both for joining me today on this webinar. It was really, really interesting to see, especially the demo. Good stuff, guys. Appreciate it.
Thank you very much. Pleasure to be here.
Thanks,
Great,
Morgan.
great. Well,
thanks everyone for your time.
Just a reminder, folks, that we have recorded today's event. So if you missed any or all of the presentation, just check the website, devops.com website, for the webinar on demand. You'll also be receiving a link in email to access the webinar on demand. You can also check devops.com for other webinars that we have scheduled. Hopefully there'll be 1 or 2 that pique your interest. But again, would like to thank you all for joining me today. I'm Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.